The uses of radiography can be seen in many fields, although the first that usually comes to mind is that of the medical field. While X-rays have brought us leaps and bounds ahead of our own understanding of the human body over the century, it also has practical use in many other industries. From architecture to art, the many facets of this marvel will be shown. Tomography is a technique used in radiology that provides clear images of deeper internal structures. It bypasses certain sections, revealing defects, rougher surfaces, and deviations from designs that are not visible to the naked eye. By analyzing the porosity, tomography helps distinguish critical defects from minor ones, enhancing confidence in manufacturing processes. Tomography dissects a solid structure into different planes, similar to how an MRI creates a complete picture from multiple images. The 3D image reveals porous layers hidden in a column, with most defects being small and inconsequential to stability. However, a larger red imperfection in this area may cause a fault and potential failure. Armed with this knowledge, the building team can reevaluate their process and construct a stronger support. One important discovery with X-ray tomography is its use in dimensional metrology. Metrology is the study of measurement, with dimensional metrology specific to a 3D space with reference to surrounding objects. In the 1980s, Ford Motor Company pioneered the use of 3D reconstruction algorithm for rotating objects using X-rays. This reconstruction was created from the initial 2D X-ray images. L.A. Fieldcamp, L.C. Davis, and J.W. Kress at Ford Motors used this technique to observe structures slice by slice and identify faults. This process, although an approximation, still helps manufacturers dissect and improve vehicles today. In research of different uses of radiography outside the medical field, there are many ways tomography was used on artwork and unveiling our history as human beings. In ancient Egypt, mummification of animals was a common practice. There are many reasons modern humans have attributed to this practice, from depicting deities to votive offerings. In our attempt to learn more about the past, previous archaeologists would break open these coffins to view the contents inside. To protect the contents of these burial sites for animals, archaeologists look to X-ray tomography to view what has been hidden from man since the first millennia BCE. Copper alloy votive boxes were typically found covering these mummified remains, sealed with a metal panel. Tomography can view past this outer structure to give detailed views on what is on the inside. This non-invasive technique allows for these animals to stay in their final resting place. Understanding a painting goes beyond just viewing it. Dating it is crucial. A painting titled Cadmus Sewing Dragon's Teeth from Paul Rubens' studio underwent tests to determine its date and place of origin. The wood paneling surrounding the painting was CT scanned to create a 3D image, allowing researchers to measure its tree rings. Comparing these rings to those of trees in Europe, it was discovered that the wood was tropical, uncommon of Netherlandish paintings of that time. The back paneling, however, was made of a deciduous oak, the most common wood used in the 17th century Netherlandish workshops. These differences indicated that the outer panels were added during a restoration project, not part of the original painting, allowing for proper dating to occur. After viewing the many ways that X-rays can be used, we can broaden our horizons on how it can be used for future studies. The uses are endless.